From day 47, the bell ringer review. This is a little fuzzy due to me like just screenshotting and trying to copy it over as fast as possible and get as much done as possible. But hopefully we'll talk about it. A lot of people miss this problem. Which function represents the data in the table? It did not say calculator inactive, so my first call out would be calculator. This would be your L1, L2. So you would hit stat edit, and then you would insert your data in L1, L2, and then you would hit stat. You would write over to calc, and then you could do len reg, which is, I believe, number 4, if I'm not mistaken. And from there, they give you the y equals mx plus b, and I believe they give you an a instead of an m. But if you know, I mean, that in itself should be enough to be able to answer this question. Without a calculator, this is a very fair question because this is a linear set of data. It's not a where you have to find the line of best fit, and it's just a loose set of data. There is a pattern. So as I go from 1 to 2, and then 2 to 3, and 3 to 4, and 4 to 5, I'm counting by 1, and you always want to check your X because it is not always by 1. Sometimes it's by 2s or 4s or, anything, and it matters. 3. If it's inconsistent altogether, that also matters. That means you're going to want to use your line of best fit if it's like 1 to 5 and then 5 to 7 and then 7 to 12. So it's not a consistent counting through of data. You're going to have to use a little bit more thinking and troubleshooting, but most likely the best would be to use your calculator steps at that point. How did I get from 15 to 26? Like if I was going from 15 to 26 linearly, because we know we're in a linear unit, right, an equation of the line, how did I get from 15 to 26? What operation? Yeah, we added 11. Thank you. And then from 26 to 37, how do we get there? Thank you, thank you. And so we added 11, and 37 to 48 was add 11. 48 to 59 is add 11. So this has a constant rate of change. Oops, I just slid the paper. Constant rate of change, which is a bit of a buzz statement for linear functions. If it is constant, like in that way, then you know it's linear. The constant rate of change, hopefully you hear the word rate of change and you think slope, and maybe we think m if we're thinking y equals mx plus b. So looking at all our choices, just knowing that means this cannot be it because our slope is 4. This cannot be it because this has a slope of 1. So now I'm down to A or C. And if that's all you can do, you now have a 50-50 shot at getting it right, making a good guess. Whereas when you just had 4, you had a 25%. And I know that seems like not a lot, but testing skills matter. Like we keep talking about, like when we take our EOC, if you can get rid of any answer and then guess if you have to guess, way better odds of getting it right. Now, so if we go backwards, that would get us to where this would be 0. And if I go back 11, so subtract 11, what's 15 minus 11? Yes, thank you. So that's going to give us 4. So if we work one more back, and remember, when x is 0, that is your y-intercept. So that means we know that the slope is 11 because of the 11 over 1, and then our b value is going to be 4 because that's where x is 0. And this is a linear set of data in the table, so we can just work backwards. And again, doing this without a calculator is what we're looking at now. So that would be your b value here. Our b value would be 0. So it would start at the origin and go up 11 over 1, up 11 over 1. So our answer is going to be 11x plus 4 because of that x value being 0 when the y value is 4, or y being 4 when x is 0. Hopefully that helped a little bit. With that being said, the next question, a ton of us missed this, and I don't know why. What is the slope of the line 3x minus 7y equals 11. Now, obviously it's not in slope-intercept form, so you can't just guess right now the way it is, but we can isolate y and get it in slope-intercept form. So get it in y equals mx plus b form. This is going to be our y that we want to get by itself. So we're going to move that 3x. How would I move that 3x to the other side? Good. So we're going to subtract 3x from both sides, and you're subtracting because it's attached by that addition subtraction here, though that negative is attached to that 7. It's not 3x times 7y or 3x divided by 7y. So that's why you're subtracting, just as a reminder. Like terms, obviously we can't put our 11 and our 3x together, so our negatives now have negative 7y equals 11 minus 3x. So we're getting close. Grade divide's not as important now. I need y by itself. What am I going to do to that y to get it by itself right now? What operation will I do? Divide by negative 7. Perfect. Divide by negative 7, negative 7, negative 7. So these are now gone. So y equals 11 over negative 7. That's our y-intercept because there's not a variable there. Remember, your slope is attached to the x, the number in front of it. We have a double negative, so it's going to be a positive 3 over 7x. Again, your slope is the coefficient of x, so the number attached to the x. So the slope of that line would be a positive 3 over 7. From the standard form, because this is standard form, where both your x and y are on one side, you will not necessarily be able to just call out the slope without a lot of practice. And I would be very careful doing it even then at that rate. All right, length and width of a rectangular garden are represented in the figure below. So we have x plus 5 as what I would call the length, and then we have x as the width. What equation would represent the perimeter of the figure? So what is perimeter? What is perimeter? Okay, so it is the addition, but if I only, so perimeter is the distance around the figure. So if I only had two sides, that would only get me halfway around the figure. So I'm going to do it again. So we have 4 sides. So perimeter is the sum of all sides. Sum of all sides. So if it was a triangle, you would add all 3. If it was, and close, area would be multiplication. Area would be multiply the 2 sides. Yep. So very close. So perimeter, you're kind of getting them both. You're giving me both answers at once. But great conversation. So 1, 2. So because this side is x, we also know this side is x. Because this side is x plus 5, we know this side is x plus 5. Because it says it's a rectangle, and opposite sides in a rectangle are going to be congruent. So you're just going to take all these and add them together. So x plus 5 plus x plus 5. Now, obviously, there's a bunch of x's and there's a constant, which means you're not going to have a number like 24 when you're done. It's going to be a binomial or a trinomial or what we would call like an expression or an equation, not x equals anything, because you aren't solving for x. You're just combining all the sides. So like what I always say is cleaning up. Combine your like terms. So we have 1, 2, 3, 4x. And then from there, we have 2 constant 5s. They are both positive, so it's going to be plus 10. So your answer for the perimeter can only be 4x plus 10. And that's as far as you can go with it. You can't make it any nicer. You can't solve anything. You don't have enough information to do anything but that. Now, speaking to area, you would multiply them, which we haven't done yet, but we're going to get into it. So that would take that one side times x plus 5. Now, you may have done some of this in 8th grade math. In our class, we have not done this yet. But x times x, does anybody know what x times x is? So this is our area. So x times x is going to give us x squared. Close. Good job, Maddie. And then x times 5 is going to give us 5x. Now, it's not 2x because when you add x's together, that's where you get the 2x, the 3x, the 4x. When we start multiplying them together is when we get our exponential laws go to work. So that would be like the laws we were doing last week. X times X, that would be the imaginary 1 exponent, imaginary 1. And when you multiply, you add them together. So this would be the area of that shape had they asked for that. And I believe that answer was in the multiple choice section for that. And I did see a couple people select it. So perimeter is just adding all the sides together. Area would be multiplying two sides because it's a rectangle. All right, which of the following equations has a slope of 3 and passes through the point 5, negative 8? So m is going to be 3, and it's going to use the point 5, negative 8. You could do it a couple different ways. So these are all in standard form again. If this was calculator active, I would go put each one in. I would count the rise over run, and it should be 3 over 1, and I would make sure it went through 5, negative 8. Without a calculator. And to call out also while I'm saying that, when you're doing your quizzes and things of that nature, if it is calculator active, I understand how you feel like there's no work to be shown. There definitely is work to be shown. And if that's an area of opportunity for you, what I would say is if you're using Desmos a ton, not a bad thing, send the screenshot. So you would make a Google Doc and attach a screenshot to it, and then that counts as work. I just need to make sure that we're not just, I guess at the end of the day, blatantly cheating and using apps or neighbors or friends. And also, the more you train yourself to use Desmos, to write things down, I know you feel like you don't need to, you do. You will be better. You will be better when math gets harder. When you rely on mental math, you make silly mistakes, not I don't know what I'm doing mistakes. And I can promise you, especially on the EOC, there's enough questions that are going to be like, I don't know what I'm doing opportunities, that we don't want to make silly mistakes because of the wording of those questions. So make sure that when you're showing that we're practicing writing things down and we're practicing using Desmos. That's the point why you get a 50% penalty on your quiz if you don't turn in your work. So you could either, like I said, plug all these in, or we could write this equation, which is what I'm going to do as a reminder, because this is a huge portion. And I know in the past in the classroom, a lot of students for some reason struggled with this all the way through the semester. So again, we know this is m, and I'm just color coding it. So we're going to write our equation. We have our x, and then we're going to do equals m. Sorry, we have our y. We have our m, and then x, and our unknown would be plus b. So that's going to be a negative 8 equals 15 plus b. We want b by itself, so we're going to subtract 15 from both sides, and b is going to equal 15 plus 8, but they're both negative, so a negative 23. Now, we know our slope, so in slope-intercept form, we're going to have y equals 3x minus 23. Now you are likely to want to move these around, and these are really, really blurry. Sorry, 3x plus y equals a negative 23 is our first answer. 3x minus y equals a positive 23. 3x plus 5y equals a negative 8. 5x minus 8y equals 3. So we know that there needs to be a 3x. So this guy here is out. Even when I move that 5 over and then divide by 8, that's not going to work. So we know that one's gone. These are all beautiful. If I move him over, excellent. If I move him over, he's going to stay 3 because there's ones on these y's. We'll talk about positive, negative in a minute, but 3x will stay the same. This 3x plus 5y equals a negative 8. If you move the 3x to the right-hand side, we're going to move him over. So I get a negative 3x minus 8 on that side equals 5y. To get that y by itself, you're then going to have to divide by 5, which is going to change our slope. It's not going to be a negative 3x or 3x at all anymore. So then we can get rid of that one. And then depending on how your brain works, how you want to think this through, don't jump too fast because there's a negative 23, negative 23. When I move that negative 3 over, that's going to become a negative 3x, which is not going to work. When I move this 3x, it's going to be a negative 3x and a positive 23, which is the opposite of what we need. But there's that negative 1 in front, so you would divide the whole thing by a negative 1, and that would change all the symbols on that other side. So your answer would be the second one in this case. You probably also could plug your x and y values into each one of those equations and see which ones come out true. Again, if it is calculator active, you could plug them in, make sure it passes through 5, negative 8. Remember x, so you're going to go to the right 5 and then down 8, and then make sure it just has a rise of 3/1 to the next coordinate. I didn't copy the question. I just wanted to make sure when we looked at these talking about correlations, this guy is a negative correlation because it is going down from left and right. It's fairly strong because it looks pretty close to a line. If this is negative, what will we call C? Does C have a correlation, and if so, what kind? Yep, it's going to be a positive correlation because it's going up to the right from left to right. So as x increases, y is going to increase. This is a positive. Again, fairly strong. Those dots are pretty close together. This guy, we could call it a vertical linear correlation, but you're not going to run into that. But it is tightly placed together, so there is some pattern in that data. And this question was which one you had to write a positive, I believe, and or a negative, and then you had a no correlation. And your no correlation is going to be A. And it's no correlation because those dots are just scattered everywhere. So it would be a weak correlation. It would be a no correlation. It's not positive or negative because you could argue. The idea is that when you're trying to decide negative or positive, there's very little room for argument. It's not perfect, but you're not going to sit there and go, well, so that would be the one you want to choose. Can I answer any questions about those? Do you guys have any call outs on where those stumped us, or maybe it wasn't you guys that were stumped, or anything that I can answer to make better on those guys? Perfect. Thank you for your response. Okay, so these guys were the highest percentage missed questions. This is y is less than 2x plus 3. Over talking, but just again as a review, we have a dashed line here. The reason that is dashed is why. Why is that a dashed line? You tell me. There's no equal to in that, right? There's no equal to in your inequality. So that's why it's a dashed line. That's y is less than. So it was shaded in the less than, like thinking about our y-axis. All of our smaller numbers are going to be down here. And then the question is 0.03 a solution to the inequality? Again, I think most students, where we mess up is we get our x and our y confused, like actually plotting the point. But 0 and then up to 3, is this point a solution to this inequality? It is not. Why is it not a solution to this inequality? Do you know? Right, it's on the dashed line. So just like I said, why is it dashed? We said because there's no equal to. Why is this not a solution? Because it's on a dashed line, which means it's not equal to. So all the things that fall on this line are going to make this side and this side equal. All the x and y coordinates that fall on the dashed line will make it an equal to statement, which is why your dashed line does not work, because that is not the case. This would be saying, so if I did 0, 3, that would turn this into 0. Is 3 less than 3? It's not. Had that been a solid line with that equal to, 3 is less than or equal to 3. So this would be a false statement because it is on a dashed line. Which pair of values for x and y will not satisfy the following system? Now, this is a calculator inactive. If it was calculator, you're looking for the point that falls in the double shaded zone. So where they overlap, both of their shadings. So you could graph this, like thinking on EOC day, or even at home, if you have graph paper, you can graph the lines and then shade it yourself. Algebraically, though, you're just going to have to work down the list and see which one works and which one doesn't. In this case, we want one that does not satisfy, so it is not going to work. So I'm going to start with 3 and 4. So I have 4 as a y value. 2 times 3 minus 1 is 4 less than 6 minus 1, which is 5. 4 is less than 5, so that one is a potential answer. For the first one, we'll go ahead and double check the bottom one, but the bottom one was going to be 4 greater than 3 minus 1. Is 4 greater than 2? It is. So again, that one's out. I'm going to go, not even worrying about necessarily, sorry, I'm making that up. We did. We just checked both of them. So x is 1, y is 1. So is 1 less than 2 times 1 minus 1? Is 1 less than 2 minus 1 is going to give us what? What is 2 minus 1 going to give us? Yep. And is 1 less than 1? No. So we're going to start this guy, checking for the second set. So 1 greater than 1 minus 1. Is 1 greater than 0? It is. It does make the second one true, but if it makes one of the equations true, can it be a solution to the system? Right. It has to work for both or not work for both. So this guy looks good for an answer. Let's check the next one. So we have a double. So 6 for x and 6 for y. So is 6 less than 2 times 6 minus 1? Is 6 less than 12 minus 1? 6 is less than 11. 6 is less than 11. Is 6 greater than 6 minus 1? Whoops, yep. Is 6 greater than 5? It is. So this one's good. It works. So that's a no-go on this one. Another misconception on this guy is missing out on will not satisfy. So we're not looking for the answer. We're looking for the bad answer. So 3 of them should work. Last but not least, let's check the last one. So 7 less than 2 times 5 minus 1 is 7 less than 10 minus 1, which will give us 9. Is 7 less than 9? Yep, good. So at that rate, we could probably stop already. We'll make sure our answers are right. Let's go with 7. 5 minus 1 is 7 greater than 4. It is, so that got out. So your answer would have to be 1 and 1. So B in this case, I guess, or the second choice answer for that one. Much easier to do when it's calculator active, but if you can tell, all of this math was fairly easy, none of which you should have to have a calculator to do to be able to do it. And they do just assign stuff where you have to do the work. It's not a quick, get to the answer quickly kind of process always. All right, which of the following systems of inequalities describes the shaded region in the graph? Again, this was not a great question. Pretty high percentage missed it. Y equals x, if we wanted to think about y equals x, that is this line always. Y equals x is a 1-to-1 slope passing through the origin, okay? None of these options have an equal to, so they're both dashed lines, so we can't get rid of one there anywhere for that. But thinking about greater than or less than y values, disregard the second line, but that blue line I just drew, is it shaded towards the greater than or is it shaded towards the less than on our y-axis? So is it shaded up, greater, or down, less than? Up. It is shaded this direction. So that means it's going to be y is greater than x with no equal to, because again, that's a dashed line. So y is less than x, that's not going to work. Y is less than x, that's not going to work. So we just got rid of A and B based off of one line. Looking at our next line, it's y-intercept is at 2. All of these have 2, so that didn't help us get rid of one yet. It is a dashed line with a 1-to-1 slope because it looks pretty close to parallel to the other. So again, we should not see an answer with an equal to in it. It should just be an inequality. And now is that one shaded up above it towards the up greater than arrow or towards the less than arrow? So looking from the orange line, it is shaded towards the less than, so it's shaded down. So that means y is less than, and you don't have to worry about the rest of it, because look at our answer choices. We have y is less than x plus 2 or y is greater than x plus 2. So it has to be C, because our D answer would have been shaded this direction from that orange line for our second equation. All right, I grabbed this one. It wasn't terrible for answer choices and how many people missed it, but I just remember there being a conversation that word problems was what kind of gives us some issues with our systems, so why not throw one in there? At healthy hair, the cost of a children's haircut is $4, and they're calling that X. So X is $4, and the cost of an adult haircut, which they're calling Y, is $14. The sales from Friday were $588. There were 42 haircuts in all. Write a system to represent this situation. Okay, what are the two totals? There's always going to be two totals when they're in this format. When they're in their standard form format, what are the two totals they gave us? Exactly. So we have total money and total haircuts, right? So we know we can get to this far. Now, what did I add together to get haircuts, like the total number of haircuts? Would I use that $4 and $14 to discuss the total number of haircuts? Do the $4 and $14 have anything to do with the total number of haircuts that we had? No, right? We had children's haircuts and we had adult haircuts. That's how we would find out how many total haircuts we had. We'd add the number of children that walked in the door and add the total number of adults that walked in the door and got haircuts. Now, your money total, it's going to do the same thing, but this is where you have to put in your money. So money gives us money as an output. Haircut gives us number of haircuts as an output. I have seen a lot of students mix those up, and I'm not sure if it makes as much sense when it comes out of my mouth as it does in my head, but when you see money and money, it has to be an output of money versus thing, which is just your X, and your Y in this case, which is adult versus children, gives us a thing output, like a count, just a count of things. So that would be how we would most easily write that equation, I think. Calculator active. Again, you could plug these in if it happened to be inactive, but it is active. So we're going to look at that one more time. Make sure we get really good at calculators. Over here. So Desmos makes it a hair easier than necessarily your TIs because it's going to give you that dash line and that solid line. Sorry, I'm trying to get my keyboard around over here. So Y is greater than 2x plus 5 was the first one. And then Y is less than negative 3x plus 5. And the solutions they want us to check, I'm going to move it up a little bit. They want to say, is negative 3 0? So is negative 3 0 a solution? Is negative 3 0 a solution to this system? So negative 3 0 is in the overlap, right? So it is going to be a solution to the system because it's in that overlap. Just to make sure we don't jump too fast and make a silly mistake, the next one they wanted us to check was 2 3. Why is 2 3 not a solution to the system? Why is 2 3 not a solution to the system? It's not in the overlap. It's not even a solution to either one because it's over here in the clean graph paper, right? So 0 5, this is a good one. It is in the overlap, but why is it not a solution? or I should say it's arguably in the overlap. Why is it not a solution, the black dot 0.5? It's on the dotted line, right? So both of them are dotted lines. So those are just parameters. That means this will not work. If they had both been solid lines, then the 0.5 and -3,0 would be solutions. So this is the only one that would be a solution. The rest would not. And so talking about, again, doing work, so like submitting work, you could easily do this. And like I said, hopefully you just saw, you can click label, you can type solution. If you wanted to say which one is not a solution, you could put not solution, dotted line. So you can add context to your dots as well, just showing you other ways to use Desmos to your favor. I know, because a lot of us get really frustrated when I say you have to show me work, but it's all in good promises. You will benefit from doing it, even though you may not like doing it. All right, second page. Write equation of the line based on the given information through 0.5, -3 with a slope of 1/5. Now, what am I missing that I wish I had to write this in slope-intercept form? So to write this equation in y equals mx plus b, what do I not have? I do not have my y-intercept. Exactly. So I have my slope, which is my m. I have an x, and I have a y. So I'm going to plug those in that place. So -3. My slope is 1/5, which don't panic. And our x value is going to be 5. And then plus b. Remember, when you multiply fractions, that's going to be 1/5 times a whole number 5/1. You work straight across the top, straight across the bottom. And that's going to be 5/5, which will give us a positive 1. So that means we have -3 equals 1 plus b. How am I going to get b by itself? How am I going to get b by itself? Good job. We're going to subtract 1. And -3, I owe you $3, and I spent another $1. That's what that minus means. So it's a -4. So our equation is going to be y equals 1/5 x minus 4. Hopefully these are getting a little easier. This was an 8th grade concept from what I've been told recently. So not saying that it was great then, but hopefully it's getting closer to great now. So the other two, again, are non-calculator active, exactly like the inequalities, except now we have systems. You can plug in the equations. You can plug, your coordinates and check to see if they make both of them true. But easier is when they're in y equals form, set them equal to each other. When it's y is and y is, that means our y's can go away. And our binomials, or whatever they say that might be, if it's a quadratic, whatever, they are equal to each other because they are the same. And then you're just going to solve it like a good old 8th grade equation, multi-step equation. We're going to get our x's on one side, so variables on one side, constants on the other. I'm going to work towards a positive variable, so I don't have to, whoops, that's going to be a minus. So I don't have to deal with negative x if I can help it. So if I have 4 and I lose 3, I end up with 1. And then these guys are gone. How am I going to get x by itself here? What am I going to do with that 1? I'm going to add 1 to both sides. So x equals 7. So that means our x value has to be 7. If that's as much math as you could possibly do and you decided you're out, number 1 and number 2, gone. So we're now to a 50-50 shot. If you didn't want to do any more math or forgot what to do next, we're going to plug that x value in, and we're going to solve. So 4 times 7 is going to give me 28. And then I'm going to subtract 1 from 28, and that's where I get 27. So our answer is going to be 7/27. And if you plug that 7 into the second equation, you should also get 7. So I'm 27, I'm sorry. So 3 times 7 plus 6, that gives me 21 plus 6. And again, you're back with your 27 because every x and y value, that coordinate has to work for both equations. Last but not least, because we're running out of time, same idea here. Without a calculator, you would want to use substitution, which is what we did the last time. It's just not quite as easy because it's not y is, or x is. Instead, it's this standard form, and then it's x is. But x is means y plus 2 is just going to go in the place of x. We're going to get rid of x because it tells me what x could also be. And when we get it down to one variable, we can come up with an answer. So we're going to do y plus 2. And then we're going to just solve it. We're going to distribute that 3. It's going to give me 3y. Then 3 plus 2 is going to give me 6. Minus 2y just falls down, equals to 5. Now you're going to clean up on each side first is my best suggestion. Some teachers tell you to do it however you want, and you can move them individually. I would not personally, because I've watched more students, not on purpose, not they don't know what they're doing, just, again, oops, mistakes, and we want to avoid those. So if I have 3y and I lose 2y, then I end up with 1y plus 6 equals 5. I need to get y by itself, so I'm going to subtract 6 from both sides. And y is going to equal, if I have $5 and I spend 6, what do I have? -1. Good. I lost one. Now, really fun part, that's the y value. So if I'm looking for my second number, that's a -1. We don't even have to do the other number. We can check it. So if y is a -1, I'm going to do x equals a -1 plus 2. I owe you $1. I paid you 2. That means you're in the +1. So x is equal to a +1, which is indeed our answer there. You could have also maybe moved your y over and put them both in standard form and then multiplied and used elimination. I would not say it's your best option just because there's so much movement going on. And again, that's just leaving room for silly mistakes. Not, I don't know what I'm doing mistakes, but just computation errors, especially when you have no calculator. You'd like to go as streamlined as possible.